the ionic compound Lewis dot diagram assignment. And again, you're going to be given a bunch of elements, find them on the periodic table, draw the Lewis dot diagram of the atom, then of the ion, and then tell me if it's a cation or an anion. Remember, AN, so anions start with an A, so they are the letter next to it negative. Cations are positive. So let me pull that up. Pull my drawing tool. And I'm going to start with the first one, selenium, which has an atomic number of 34. So we said, why is it not drawn? Sorry about that. Little technical difficulties. We said this had an atomic number of 34. Remember, 2, 8, 8, 18, 34. So 2 will go there, 8 will go there, 8 will go there. That's 18. That leaves 16 here. So 16 is 2 short of, basically, you're going to subtract 10. So 16, we're not going to draw 16, we're going to draw 6. And this deals with the s and p orbitals, but for us, if we get this high of a number, just realize anytime we get to double digits, we're just looking at the singles digit. So I'm going to draw Se. We said there's 6 electrons, so 1, 2, 3, 4, 5, 6. You'll need to do this on your own paper if you didn't grab a printed copy. The Lewis dot diagram of the ion. What you're going to do here is you're going to get rid of all your dots or gain enough dots to make it full, but as many electrons as you're gaining or losing, you have to put that as positives or negatives. What do I mean? That sounds confusing. Well, we need to gain 2 here, right? Gaining 2 negatives is a 2 negative. And then I just draw my 6 that I had plus the 2 that I gained. This is negative, and we said negatives are anions, so I'm going to put an A over here. All right, let's do calcium, which has an atomic number of 20. 2 go on the first level, 8 go on the second, 8 go on the third. That's a total of 18, so there's 2 left over. So calcium has 2 valence electrons. Remember, if you know the trick, you can just look at your top of your columns and it'll tell you the number of valence electrons. So calcium has 2. Well, what's going to happen to those 2? We're going to lose them because then this is already full. Remember, we're going to always do what's easier. We could gain 6 or lose 2. Well, 2 is a smaller number, so we're going to lose those. So we get rid of those 2, and when we're losing electrons, it becomes positive. So it's just Ca2 plus, because there are no valence electrons. Well, there's no electrons around it because we lost the 2. If it's positive, we said it's a cation. You'll go ahead and fill out the rest of this table here. And then when you get down here, we're giving you some names because our next unit's going to be naming, so we'll kind of get used to that. But we're going to have formula units and then our Lewis dot diagrams. So let's practice one of those. I've done sodium chloride enough, so I'm going to do potassium oxide. Here's K, 19, but remember, I'm going to give you the cheat here. Anything in row 1 has 1 valence electron. So these all have 1. Oxygen is over here. And remember, everything over here has 6. So let me pull out my drawing tool again. We said potassium has 1 valence. Oxygen has 6. Yep. So my formula actually should say K2I, and I'll show you why in a second. And that makes it a better example as well. So if you have 1 valence electron, what's going to happen to you? You're going to lose it. So just like above, K loses an electron and becomes positive. I needs to gain 2 electrons, which would make it a 2 negative. And that's not balanced. 1 and 2. That's why we needed to put K2 there, and we have another K. So this is what we're going to look like. When we gain those 2, that put 8 around here, and we lost those, so those become positive. So we translate this over here. K positive. The I, just like we did above, with the 8 around it, but just as importantly, that has to get a 2 negative, and then the K positive over here. So this one, I'm not going to do it for you, but you're going to have Al next to 3 different Fs. But you'll have to figure out where the dots go and what the charges are based on the periodic table.